All right, let's try this instantaneous rate of change problem in a little bit different way. Let's do it as two separate points. So I've already got our picture drawn here this time. We know inverted parabola, we're interested in what happens at 2 seconds. So I've got the point 2 comma 29 that is on the graph, and some other random point at t comma negative 4t squared plus 20t plus 5. It's just some other point on the graph. And what we're looking for, again, is we're going to make a line through here, and we'd like to squeeze these 2 points very close to each other. Okay? And so the t, in this case, what we're doing is trying to get the t very close to 2, so we can phrase it this way. Let me find the limit as t goes to 2. And since this is an instantaneous rate of change, I'm doing a change in y over change in x. My change in y here looks like it's going to be, I'll try to color code as I go. I've got the 29 minus the negative 4t squared plus 20t plus 5 over 2 minus t. So it's a little simpler to begin with. Let's go ahead and see where it takes us. So if we tried to just plug 2 in, I can see already I'm going to have a problem with the 0 in the denominator. If I plug a 2 into the numerator, I also get 29 minus 29, so I get 0 over 0. We've seen that that's different than a number over 0, and that there's some hope of actually coming up with a number here. So I've got a 29, I'll distribute the negative through, plus 4t squared minus 20t minus 5 over 2 minus t. Let's see, what else can we do? We can do some combining here. This is a limit as t goes to 2. 29 minus 5 is 24, plus 4t squared minus 20t over 2 minus t. Well, I kind of like to rearrange that a little bit. I don't like my quadratics looking that way. So if I went with a 4t squared minus 20t plus 24 over 2 minus t. Couple of things here. One, because I know that putting a 2 into the numerator makes it equal to 0, I know that a 2 minus t will factor out of that. So I could just try to do that at this point and say I'm going to do the limit as t goes to 2, and say I know I have to be able to get a 2 minus t out of there. And so that must mean that there's a minus 4t to make the positive 4t squared. And to get my constant, it would have to be plus 12. And I could verify that that gives me minus 12t minus 8t, which is the minus 20t. So that is the way that it factors. Factoring is important in calculus, but it's easier than it was because you usually have clues. And I can see what I end up with here is this 2 minus t divided by 2 minus t, which most of the time is equal 1 as long as t is not equal to 2, but I'm taking the limit as t is approaching 2, so I'm not actually going to land at 2. And this gives me then the limit as t goes to 2 of negative 4t plus 12, which I will now at this point, since this is just a polynomial, I know I can find that limit by plugging the 2 in, and that'll give me a negative 8 plus 12, which is 4, so my instantaneous rate of change is 4 meters per second. Okay, that went a little bit faster, but I set up some stuff earlier in there as well.